Alrighty, yes, Brian will be in the front. Alright, hi everybody, thank you for joining. My name is Teo Gonzalez. I probably met most of you at the front, aka your doorman for the evening. Really excited to have you all here for this month's edition of Data Bytes. We're really excited that our partners Vectara and Teradata were also interested in getting together to talk about extending your data platform. The main stars for the night are over here, and you're going to get a chance to meet all of them one-on-one. So I'm just going to shut up and get off stage over here and pass it over to Brian Leonard from Airbyte.
Oh, yeah. Yeah, give it up for Teo. Strong door handling today. All right, talking about extending your data platform today here. And what I'm going to do is talk about stories. This is going to be more of an English literature kind of lecture. All right, so how these work, it's a graph, it's data. On the bottom is bad fortune. On the top is good fortune. And this is like the story from the beginning to end, how this thing goes. All right, so what is this one? This one's called Fall from Grace. For example, Old Testament didn't go well for a few people. So we started out, we were getting land and birds and people, and then everything's looking pretty good, and then someone ate an apple, basically, and then it went down, and now it's not so great. That's that story. A very similar version of that story looks like this. Cinderella. So the cleaning is no good, and then they got some carriage and a dress and all kinds of things, and then we're dancing at the ball, and then she lost her shoe, and now she's back to cleaning. It's not as bad as it was before, because she'll always remember that night. But then, someone with a shoe found her or something like that, and now life is great to the infinite. All right, so this is about stories, and I've got a story called ETL Platform Adoption. And I think it looks a lot like the Old Testament, for better or worse. In the beginning, and we were adding sources, and everything's looking pretty good. We're adopting this ETL platform. It's all handled. Everything's looking good. And then we get to this spot where we need data from a source that our platform doesn't know about it. And then we just fall to the bottom. It's not quite as bad as it was before, because we'll always have a few of these sources, but it's not great. And now I still have to build and monitor a production pipeline. So now I got this system over here, and it's kind of helping me. That's nice. But over here, I'm back to being on call for X, Y, and Z sources, which is not so great. So the obvious question is, how can we Cinderella this situation? And what that looks like is called extensibility. So everything here, same. We need a platform. We need some data that our platform doesn't know about. Now here, the shoe, I guess, or something like that, is building a connector. And when we deploy that connector to my data platform, life is great. So I still am only working with one system. I'm only monitoring that one system. Even better if someone else is monitoring that system for me. But because I was able to extend that platform, I don't have this dual-headed world, and I can just continue on my way. And for any source that I don't have a connector for, or destination for that matter, I'm able to build a connector and have that working out well. Is that right? It's good? All right, so if I was building a data platform, which I may or may not be, you'll surprised at the end for sure, what are some good design principles for that? One of them is about specifying our abstractions for how the platform and the connector are going to work together. So if we're going to be able to handle just about anything, what is the right abstraction so that the connector is a black box for that platform? I'll talk a little bit about that. The important thing there is not to allow any special cases. If there's one snowflake, you already did there? Snowflake? If there's one snowflake that acts a little bit differently, that has to be part of that protocol that you're using to talk between the platform and all of the connectors. Then as far as you're thinking about extensibility, we think about how we can make the hard possible. No matter how hard it is, it's at least possible to be able to accomplish that, so you don't have to stay out of the Garden of Eden or whatever, and stay in that one platform, and make the common thing incredibly easy. So as we're going through those, let's talk about that. So how does Airbyte at least go about specifying abstractions? We have this protocol published up on the website. We highly encourage anyone to use this protocol if they're thinking about even building their own platform. It seems to be pretty good. What it does is it's like Docker, Kubernetes container kind of based kind of thing. And so the way you do that is that whatever you want inside of that source container, it can do anything it wants, super flexible inside of that black box, but it's going to get instantiated a certain way. Its job is to output basically to standard out, and the platform will read that. It can do whatever it wants and output a certain way, and then there's a way to, in the same sort of way, through input to another destination container, can give it that data. In the middle, we're orchestrating all of those things, but it makes it super straightforward. Basically, any given script to be able to write a source. Another way of our protocol works logically is outputting our records, outputting states so we don't have to start over, the way you implement incremental syncs, like start over. So you don't have to do records yesterday that haven't changed, for example. And then we checkpoint those in the destinations. This destination is up to date through today at noon. And then now we know we don't have to read the source from again. So the protocol talks about how we send the data back and forth. We can't allow any special cases, so everything must go through the protocol. And so whatever one connector can do, they can all do, and then we evolve the protocol and we make those nuances declarative. So if there's anything weird about that one, it can say what's weird about it, and the platform knows how to handle it. We make the hard possible through that container approach. And so basically you can have whatever you want. I've seen a bash script connector, like sure, why not? Inside of that connector, Python, Java, Kotlin, there's TypeScript ones and bash ones. As long as it outputs the right data, you can extend Airbyte by making that connector up on and download them. Airbyte can download any connector from Docker Hub. Make it a little bit easier. Python's super common. A lot of data engineers like Python. We have a CDK, so you extend these certain classes to write your custom connectors. This is easier than operating at the operating system and container level, but still making it a little bit easier, but just about anything possible in that language. And we make the common easy. So we have this declarative low-code CDK approach, basically for API connectors. Most API connectors look about the same. You do some usually GET requests, you parse that in a certain way. Sometimes you have to go into the response in a certain way. Pagination works a certain way. Incremental works a certain way. But the most common patterns we've put into this YAML format such that you can just declare those. And then just that YAML file basically is your connector. In this case, it's doing a GET request given the user fills out an access key, for example, to get the exchange rate data. And then you deploy that. There's scripts to put that up on Docker Hub, and you can pull that into your OSS or cloud Airbyte instance. And then we try to make the common incredibly easy with this thing called the connector builder. And so basically, it's kind of like Postman, where you're messing around with the API calls, and it's basically outputting that YAML format that we talked about. So click, 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 and you deploy that, and you're done. I'm going to demo what that looks like, if you're interested. We good? All right, that's good. All right, so what we're going to do is start one of these from scratch here. I'm going to do a SendGrid situation, and I've got the SendGrid was bought by Twilio, so let's go over there and figure out the URL that we're going to do. What I want to do is pull in my base URL here with sendgrid.com and figure out how the authentication is going to work. So we check out authentication, and we see here that we need an API key, and it uses this bearer kind of approach. Put that in. And I've had to figure out my token in a second, but first let's add our first stream. And so the one I'm interested in is called bounces, and so we can put that in. I did this before, obviously, so there's a typo ahead there, but what I would do normally is go in here and find the URL that we're going to get all those bounces from. And it's v3/suppression/bounces. Put that in here like that. Cool, and then I can test it. It's not going to work, of course, because I haven't put in my API key. So let's get that, paste that in there. Cool. So, no, stop it. Okay, now, there we go. So now we can test that. We can see what the data coming back looks like. All these invalid URLs that we had. The response that came back and all of that other stuff, but basically this is the data that I want, and it figures out the schema, and we can go from there on these records. Now we don't need a record selector because it's in the root, so we'll skip that. I believe this has pagination, even though I only have 6. How many does it handle? 500 there. That's good. It's using this limit and offset approach. Can do that. So we put in the limit 500, and is that right? Okay, good. 500, and then we'll say limit here and offset here, and then we'll do that. Now it'll be exactly the same, probably, because I didn't have 500 of them. But I can put in 2, and then instead of limit equals 500, it'll put limit equals 2, and then I'll get a few different pages. Checking that out, looking good, different pages, very good. Now I want to figure out how to do this incrementally. So if I do have thousands of these things, I have to figure out a cursor, basically, that I can pull from. So there's this created which looks like a epoch time kind of situation. It helped me fill that out, and we can figure out how that goes into the URL. With this start time and end time in this case, we'll fill that out, and then test that. Now it needs a start date because it wants to know, because I need the initial input basically. So we'll set this pretty far back. Old school. Remember January 21? Oh man, that was a time. All right, here we go. So now the response, let's check out the request that I made. It said start time equals this and end time equals that. It's sort of walking the world forward, saving the state as we go and things like that. So then the next time that we do this, it'll be in the right, we'll pick up from where we left off, basically. Yeah, so basically that's all we have to do to make a stream here. The cool stuff starts to happen when we have another stream, and APIs are often super common. So I happen to know there's this one called unsubscribes, which they call global suppressions, which also have start time and end time and all these sorts of things. And so we can basically duplicate this one and put in global suppression like this, not unsubscribes, and change the URL. Get all the typos right, and create that. And it's basically a copy of that since it's using the same patterns. And I can test that. And that's good to go. So before we actually deploy this, we'll probably put this back to 500. Okay, fine, we'll do 20 first, and then we'll put it back to 500 just to make sure it's working. And then we can deploy that, and it'll automatically pull all of the data in from both of these two streams. And we publish that, and there we go. So that's how the connector builder on Airbyte works. And super bonus coming soon. We're going to make it crazy easy to share what you've already made. So basically put this on GitHub and share with a marketplace kind of idea. And so we expect to see a whole bunch of these connectors that are relatively easy to make, and finding them from your peers, your data engineers, your data analysts from other companies, and you can check them out, and they can either be exactly what you need or at the very least a great start for the sources that you have. That's it. That's what I got to show. Questions?
I have time for 3 questions max, so if you want one, get your hand up now.
So, you showed that you need to enter secrets. Do you have a secrets management system, or how are you supposed to manage secrets?
And can you restate the question?
Yeah, sure. So I'm managing secrets, and how is that being managed? And is there a secret manager built in? Can you use your own maybe, or something like that? It's something I've heard before for sure. Cool. So in the Postman kind of connector builder thing, like that secret's only stored kind of locally in cookies or something like that. And then that obviously does not get published when you publish it out, especially to other people. When you set up a source in Airbyte, you say new source, and then you put in the configuration you need to do that. You put your API key in, and then it gets stored in cloud, for example. It gets stored in Google Secrets Manager. Is how we handle it. When you deploy this on your own, you can configure the Secrets Manager to be a few different things. Does that answer the question?
Yes.
Cool. Thank you.
Yeah, they're courageous souls. All right, let's go.
So, when you build a protocol that tries to, give you access to all these different kinds of connectors, like the connectors themselves have their own native language in which, their own native protocol, like SQL or whatever.
Yeah.
So, when you try to come up with the lowest common denominator, what do you find yourself giving up, right? Like, are there sort of limitations that you run into? Okay, that there are some capabilities that you're going to have to give up to achieve this symmetry, and what are some of those important things that you end up giving up?
Yeah, super interesting question. So when you're making a protocol that works for everything, what are you giving up? What are you losing? Because if you work for everything, you can't optimize for anything, maybe, or something like that, right? That's super true. And so there's different ways that each of these connectors work. For example, we have plenty of connectors that are SQL-based, and we have other ones that are API-based on sources, and slightly different. There's the S3 and Friends that are kind of file-based. Those are three different types of things that we have going on. And so the choices there is I think the real, first of all, the important thing of making a protocol like that, to the best of that I've learned so far, is certainly don't specify anything has to be done a certain way if you don't really care about it, right? And so the platform only needs those records, and so let's not talk about anything else other than here's some config, give me back some records, and they can do whatever they want. And we have a lot of time spent in the way to optimize talking to Postgres, for example, in order to output those records. I think a really interesting spot that Airbyte is in, that if we were super focused just on SQL, for example, that we might have done differently, is kind of like a performance-related thing around those records. So if you were making only a SQL optimized source system, you probably wouldn't have a protocol that worked one record at a time. If you knew you were going from SQL to something like Snowflake that looked like SQL, you'd probably be moving around 10,000, 100,000, I don't know, lots of records at a time in more of a CSV format, or maybe some sort of Parquet format or something like that. But because we're trying to normalize it and make it really easy to extend, we're outputting JSON on standard out, which is thinning that pipe a little bit, right? And so, that doesn't mean in the future we won't do something that optimizes those particular use cases, but by going down to the common denominator, we left some performance gains on the table for higher performing systems, probably, by not doing them in bulk like that. One example.
And other questions? All right, give it up for Brian. It's off. All right. Thank you, Brian. Thank you, everybody. We're going to be bringing on our next speaker while I go put my glass slipper on later. Janeth is going to be talking about everything she's doing with Teradata, the relationship with Airbyte, and also the great things you can do when you're working with Teradata. Off to you.
Woo!
Good afternoon, everyone, and thank you so much for being here today, for coming out, and to the organizers for inviting me to speak today. Very excited to be back in the Bay Area. I actually was living here for about 6 years while I was studying at Berkeley, and then when I started my career in DevRel, developer relations, as a developer advocate for a startup here in San Francisco that was building a Node.js platform for integrating APIs, similar to what Airbyte is doing today, actually. And yeah, after about 5 years, I decided I wanted to move back home to sunny San Diego, and I was very lucky to find a job there with a really good company, Teradata. They are also headquartered in San Diego. Now, before I dive into the presentation, I actually would love to get a show of hands to see how familiar you guys are with Teradata. Has anybody here heard of Teradata? Awesome. Good to see that like about half of you guys have heard of Teradata. How many have you actually used Teradata in a prior company or currently? Okay. Like 2 or 3? Perfect. Awesome. And now I'd love to get to know you guys in the audience. Can I see a raise of hands for how many data engineers we have in the audience today? Okay. Data scientists? Data analysts? Developers? Awesome. And data architects? Great to know. Thank you so much, guys, for kind of giving me an idea for who's in the audience. I love to connect and get to know who I'm presenting to today. It also allows me to know when to slow down or what to emphasize. So to give you a quick high-level overview of today's agenda, I'm going to talk a little bit about Teradata so you can become familiar with the platform. And then I'll talk about our partnership with Airbyte and why we decided to partner with Airbyte. I'll also go into how Airbyte and Teradata are advancing AI, ML, and advanced analytics. And finally, I'll talk a little bit about the development of the Airbyte connector and end with a live demo if you guys would like. So that will be up to you guys at the end of this presentation. So with no further delay, I'd love to get started talking about Teradata. Teradata is a leading multi-cloud platform for large enterprise analytics. Now, we've been serving the world's largest enterprises for the last 40 years. We empower these companies to derive actionable insights from vast amounts of data. We help companies in the airlines industry, in banking, telecommunication companies, healthcare providers. All of these clients are relying on Teradata for critical AI, ML, and analytic workloads. Now, what makes Teradata the most complete cloud analytics and data platform for AI? Teradata offers data warehouse, lakehouse, and data lake architectures. And they can be deployed in any cloud service provider, including Microsoft, AWS, and Google Cloud. We are an open and connected platform, meaning we support data in object store. We even do read and writes to data lakes, like Iceberg and Delta for seamless data access and analysis. So where we really do well is in end-to-end AI ML pipelines. From ingestion to deployment, Teradata makes it really easy to build your AI ML pipelines. We can start over here on the data preparation side. We offer in-database functions that we call ClearScape Analytics. These are a set of 150 in-database functions that data engineers, data scientists can use to explore data, clean their data, feature engineer, deploy their models, and we even offer the ability to train your models externally. We have integrations with Azure ML, Vertex AI, and if you wish to build a model externally, you also have the option and deploy it to scale on Teradata Vantage using our Bring Your Own Model capability, BYOM. We support Onyx files, PMML, and H2O.ai. And finally, we also offer ClearScape Analytics Model Ops for your model observability and governance. The reason why we partnered with Airbyte is because we make this end-to-end AI ML pipeline building a seamless process, from data ingestion to deployment. And Airbyte is a very important part of this process. The fact that it is open source ensures that the open source community is maintaining the connectors, the source and destination connectors up to date. And the fact that it has over 300 connectors makes it very convenient for our large enterprises to be able to ingest data from a variety of SaaS applications. We're talking about our customers who work with many SaaS platforms across different departments. So it's very convenient for them to use Airbyte to ingest their data, as well as the ease of use. Teradata, Airbyte's user-friendly interface just makes it really simple to ingest data, to schedule ingestion workloads, and also it has various configuration options, as well as different features that make it really simple to collaborate with your teammates on Airbyte Cloud. This ultimately helps our customers at Teradata derive more insights from their data. Now, while I don't work on the team that built the integrator, that's actually our third-party integrations team. I work on the developer relations team. So my team is responsible for testing the connectors, for building demos with these connectors, like the one I'm going to show you at the end of this presentation. So we do work closely with that team, relaying feedback. And I'd love to share some of the insights that the team shared with me in case you're considering hosting your connector on Airbyte, or if you're in the process of adding support for Airbyte Cloud. Our team had the option to build the connector with the low-code tool that Airbyte provides, as well as with Python or Gradle. Our team opted for Gradle for their just proficiency with Java. And they mentioned that it was very straightforward to build, very easy process, as well as that they really appreciated the Slack workspace to have access to the community and to the team to be able to have their questions answered. In addition to that, make sure I have enough time. So the open source connector was published March 22, and then the progression to the Airbyte Cloud connector was very easy decision to add support for our Airbyte Cloud to our connector, given that it was just going to be another way for our customers to be able to ingest data into Teradata Vantage with less of a hassle. It removes the infrastructure setup and management when Airbyte Cloud provides that for you. So that was an easy decision to make, and we published our Airbyte Cloud connector December of 2023. And we're very excited and looking forward to what's coming next for the Vantage Cloud connector on Airbyte. With the release of Airbyte's V2 architecture, we're looking forward to adding append and dedupe functionality, one-to-one table mapping, improved error handling, and incremental delivery for large data sinks, which is going to make the ingestion process into Teradata Vantage a lot more smoother. So we're very excited for that. That's coming next. Now, I did want to take a moment to place Airbyte in the data lifecycle. For any of you who might not be very familiar, so on this side we have various sources from your SaaS applications, message streaming platforms. We start the first step, a very important step in our ELT process using Airbyte. For low to moderate levels of data, we recommend using into Teradata. We recommend using Airbyte, the connector on Airbyte, to ingest directly into Teradata. For higher volumes of data, over, I'd say, hundreds of gigs, we recommend sending that data to Object Store using Airbyte. whether that's S3 or Microsoft Azure. And then from there, ingesting it into Teradata with Native Object Store or Flow, our proprietary tools. Now, once the data lands into Teradata's environments, whether it's Vantage Cloud Lake or Vantage Cloud Enterprise or Warehouse, that's where the transformation process begins here. You can leverage our in-database ClearScape Analytics functions that streamline the data preparation process for your various needs, right? So these functions are going to be pushed down to Vantage so that Vantage's massively parallel processing power can perform the transformations. And this is where you would leverage our ClearScape Analytics functions. You could also embed them in your DBT workflows. How many of you are familiar with DBT? Can I see a raise of hands? DBT is an open source data build tool that makes it introduces a lot of features, best practices of the software engineering world into data engineering. And it's just a really organized way with a lot of features to build your models. So you can embed your ClearScape Analytics functions into your DBT workflows, push them down into Vantage, and perform your transformations. And at the end of the data lifecycle, we also offer various tools to integrate with your consumers, whether you're consuming your insights from BI tools, from applications. We have APIs, drivers, and integrations with a lot of the popular tools like Tableau, Power BI. And this is a complete representation of the data lifecycle, and this is where Airbyte fits into this process. I just wanted to contextualize where Airbyte is for us. Now, for the first time ever last year, Teradata Vantage released its very first website where you can provision a free environment on Teradata and explore our analytic engine for AI and ML. So who doesn't love a free space where you can code for free, execute your code, and it's complete with over 80 AI ML use cases across different industries that you have access for free in a Jupyter Notebook environment. You could also connect it to third-party tools. You can connect it to Airbyte, begin ingesting the data, begin transforming the data, and connect it to any consumption tools or any visualization tools, and just get a sense for how powerful Teradata's analytical engine is. And I wanted to invite you guys to scan the QR code and sign up. You make my team very, very happy to see anyone that's actually interested in having access to this free learning material, explore it, and provide feedback. You won't be targeted with any marketing campaigns. It's strictly a space for us to learn. I've been leveraging it on my end to learn a lot about different processes and model building. So we've reached the end, and I would love to give you guys a demo if you guys would like. I'm thinking of ingesting, if we have time.
Yeah.
Do it.
Do I need the microphone?
Yes.
Okay. I need both hands, so I'll try my best.
I can hold the mic. If
Can you
like.
hold the mic? Yeah, that'd be
I got you.
awesome.
Brian got it.
Thank you. Okay.
Brian.
Thank you.
Stay like that for the whole time.
Okay. So let me
Workouts for this moment.
exit out. I will need to see my screen.
Yeah, you
can
need to
hold
see
it.
your
Yes,
screen. I
yes,
think we'll have to
thank
go
you.
down here.
Perfect, that works. Okay, so a little bit about what we're going to be doing. We're going to be using the Vantage connector on Airbyte to ingest data that is sitting in Google Cloud Bucket in CSV format, right? For the purposes of this demo, I've already set up my source and destination. As you can see, we have online retail data. It's in CSV format, and our destination is already configured as well. I've configured it to point to Vantage Cloud Lake. Now the connector in Airbyte, the Vantage connector, supports syncing into any of our Vantage Cloud Lake, Vantage Cloud Enterprise Warehouse editions. Any of our editions are supported. You simply set the destination name, your host the host to the database, the user that you want to give access to read and write to your default schema. For this, I've set aside a database called demo to demonstrate this execution, this data sync. And then we're going to take it a little further than that. We're going to extract insights from our data set, from an online retail data set. And then I'll quickly cover the data set once it lands into Vantage. Okay, so we have source, destination setup. So we build our connection, right? And prior to doing this 3 hours ago, I performed a quick test to make sure everything was running well. So let's sync it again. I cleared the tables, and we're going to perform the sync. Sync now. So we can see it's starting, the sync is starting. And meanwhile, it takes about 2 minutes, 30 seconds. I'm going to turn to Teradata's Vantage Cloud Lake. Our lake offers separation from compute and store, and you can also provision independent clusters to run your heavier workloads. You also have more insight into how your queries are running, your consumption. You could also set guardrails in Vantage Cloud Lake within your environment. For this specific demonstration, we're going to be using the editor. And I've set up a user, data engineer, that's going to give me access to my database. Inside I've created a demo database I'll be using a demo database for this demonstration. We're going to be syncing data that's going to land in here. If you guys are familiar with the way the data lands, it's going to be sent in 3 columns. So let's see if our sync has completed. It's still running.
That's on us. That's me. Sorry about that.
It's the internet. It's a little slow. So just to check, I do have an empty table called Airbyte Raw Online Retail Events. I cleared the database. So let's go back and give it a few more seconds for our data to sync. Do I need to zoom in? Are you guys able to see?
Just a little bit, yeah.
Okay.
Nice.
Okay. So we're going to be syncing around 8,000 records of retail data. And it's been a lot faster than this. I do blame it on the internet.
You did take $1 and put it in Brian's pocket.
Yeah.
So I guess I can talk a little bit about the data set since I'm familiar with it. So we have 8,000.
Oh, it happened.
It happened.
There we go.
2 minutes and 26 seconds. Okay, so our data should have landed in Vantage Cloud Lake if we execute this select statement to retrieve our data inside our online retail events. We see our result. I just gotta bring this up. Here we go. Okay, so we see it landed in 3 columns. Airbyte appends that ID to it, and the data lands in JSON format and a timestamp. So the next thing we need to do is we need to shred this data really quickly, right? So let's go ahead and do that. Let's create a table where our shredded data is going to land. We're going to call that retail data normalized. And next, let's send that data over. Are you guys able to see? Let's zoom in a little more. Okay. So we're going to insert data into this table I'm calling retail data normalized. So we can see the data in tabular form. Okay, awesome. So here we have it. We see a table with 3 columns, entity ID, date stamp, and event. And we have 8,900 records. So imagine trying to just manually extracting insights from this data set. It's humanly impossible. It would take, not even days or maybe a year. I couldn't do it with the eye. So what we're gonna do is we're gonna leverage Teradata's in-database functions to speed up our data preparation process and our data analysis process. So what we're gonna do is we're gonna use our sessionize function available in Teradata. Our sessionize function is going to append in an additional column. We're gonna create a table and append another column to this data set with session IDs. Now, what this function is doing, it's scanning through the entire data set and appending a unique identifier to the actions of a user within a specified period of time, right? So let's say we want to find the actions of a user within a 24-hour period. So we're gonna do that with our sessionize function. And Teradata Vantage Cloud Lake has this really neat in-database analytics function explorer that gives you access to the 150 in-database functions for data preparation, data cleansing, feature engineering, model deployment, you name it. There's a lot of functions available. We're gonna select our function for path and pattern analysis. So we begin with our sessionize function to prepare our data set. So what we're gonna do here, we're going to, now that we've normalized our data, we're going to select the database where we want to create a new table with sessionized data. And we're going to call it retail sessionized, let's see, what do we want to call it? Retail sessionized data. Okay? And we're going to select the input tables or the tables we want to execute our sessionize function against. So for that, we're going to select our database, demo, and our table is retail data normalized. Retail data normalized, there we go. And the parameters that this function takes is a time column. So we have that, that's our date stamp, and a timeout. So let's say we want to set boundaries for our sessionize function. We want a sequence or events stitched in a period of 24 hours. That's 86,400 seconds. And I think this should be it for the in-database analytics functions explorer to build our query. So we select view query, and we can see the output here, the create table statement. So we can copy this and execute this. So I will exit out of here and comment this out. And let's execute our sessionize functions against our shredded data. So let's select run. Actually, let's review this. So we're doing a create table we're creating a table called retail sessionized data, and we are taking the retail data normalized table as the input table, partitioned by any. This needs to be partitioned by entity ID. And we select run. So within seconds, Teradata Vantage Cloud was able to append that additional column, and now all of our events have a unique session ID identifier. Now the final step in this analysis to surface insights is applying our empath function. What we're going to do with empath, we're going to execute it against our sessionized data set to identify paths leading to an event. So as you noticed, our table consists of events such as product browsing. So this is data from an online retail store, right? And we've noted whenever a membership has been canceled, whenever some product has been purchased, whenever a customer has been browsing a product. So we want to understand why our members are canceling their memberships. For this, we can leverage Empath after we've sessionized our data. So we open up our in-database analytics explorer, we select our Empath function if we need a little assistance building the query. So we're going to select our database and our demo sessionized events. From here, we want to select any event leading up to a membership cancellation, and we want to find a minimum of 2 events and a maximum of 5 events in this path leading up to a membership cancellation. And we want to, let's say we want to output the top 10 paths leading up to membership cancellations. We select our session ID column and view our query. We copy it, drop it into our editor, and execute. And within seconds, we have the top 10 paths leading to membership cancellations. We can see that we have 14 paths that had a web chat before they canceled their membership, 8 paths that performed a return policy inquiry and then canceled their memberships. So with this, we could even further analyze. We could feed the web chat text or the return policy inquiries or any of the calls that were received before a membership was canceled, apply sentiment analysis, and even surface further insights from this. This is just a quick demo to showcase how these large enterprises like retailers are using Teradata's Vantage Cloud Lake and ClearScape Analytics to surface these insights from vast amounts of data. Just to give you insight into our capacity, one of our customers in the transportation industry has 43,000 tables with 3 trillion rows and is ingesting 4,000 is doing 4,000 ingestion jobs daily. This is how much we are processing on a daily basis. That's just one example of one customer performing these type of analysis in real time too. So just a quick introduction to Teradata, and if you guys have any questions, happy to answer those questions.
All right, and there will be time at the end of the presentations as well that you can continue mingling, so we're going to save Janet's questions for those. Let's do one more round of applause for her and also welcome over to the stage. And let me make sure you're good to go. Perfect. You had Brian so hooked he didn't even notice the pain in his arm as he held the mic. You know, working out, you're doing good. All right.
All right, hi everyone, I'm Ofer from Vectara. Thank you, Brian and Janet, for the great presentation, stories, and great demo. So I'm from Vectara. A little bit about myself, I also do developer relations for Vectara. And one of the things that makes me excited about, I'm going to talk to you about LLMs today and RAG. And I was fortunate enough, I should say, to use RAG kind of early on. An LLM since about 2019, when it wasn't cool, when it was as it is today. So, but got to see this space evolve over time. So, LLMs are great. We use ChatGPT and others, but they still hallucinate. So one of my favorite examples is this: did Will Smith ever hit anyone? If you ask that of GPT 3.5, it says no. You know, he's a pretty cool guy, never been aggressive. But we all know what really happened, right? Which is this. So they do hallucinate. And who here, show of hands, who here heard of RAG, knows what RAG is? Okay, quite a bit, great. So retrieval augmented generation, I don't have to tell you too much about it. For those who don't know, it's a way to use LLMs with your own data. You know, in a regular kind of LLM flow, if it's just the LLM, you ask a question of the LLM and it just answers based on its training data. But with RAG, what you do is you put your own data here. Could be, you know, hundreds of thousands of documents, millions of documents, and in real time when the user query comes in, the RAG pipeline essentially has a retrieval engine from that data, from your own custom private data. It pulls the most relevant facts and essentially tells the LLM, please answer this question, but here's some additional information that should be really relevant. And then the LLM uses that information. That's why it's called retrieval augmented generation. One way I like to think about it is like an open book test, right? Where you take the question and you can look at all the books and figure out, and you have to have a good retrieval, you have to understand the books. But generally, that's how I think about this. Why would we use RAG? A couple of reasons I want to highlight. I said earlier it can be done with your own data, your private data, your enterprise data, and it reduces hallucinations. That's a great first one. But also, I want to mention in a context, with Vectara, I work a lot about hallucinations, reducing hallucinations. We also introduced recently something called HHEM. If it's interesting for you, check it out. It's on Hugging Face. It's an open source model to detect or evaluate if a response is a hallucination or not. So a pretty useful thing in this space. This is the leaderboard on Hugging Face. You can look. And it's really interesting because the leaderboard allows you to see that not all LLMs are the same. So GPT-4o, for example, is pretty good and has lower hallucinations than many others that have higher, so things like that. Second thing is RAG outputs are explainable, right? So when you have a response, or they could be explainable, they have citations. When you have facts that the LM bases its responses on, it can show you, okay, here's where I got this from. So you can go as a user, if you don't trust it enough, you can go and click on these citations and see where it came up with the answer from and get more interest. It's also private. There's no training of the LLM. Your data doesn't leak anywhere and goes to other parties. It's very safe in that way. So that's a big important thing. Because you don't train on GPUs, you don't have to fight everybody else on these resources these days. You have to pay NVIDIA a lot of money. It's relatively inexpensive because it just does a lot of retrieval and then calls the LLM to do the generation. So there's no training involved or that kind of thing. And one of my favorites is that it actually allows you to do permissioning with LLM kind of data, because you can, for example, if you have data from Google Drive and part of it is the secret HR, or not secret, but confidential HR folder, you can in real time when the facts come in, have metadata on the fields and say, do you have permission to see this data as the user? If not, I'm not gonna give that information back to the LLM before I ask it to respond, so it doesn't respond based on data that you're not supposed to be able to see as a user. So that's a really, really useful thing to do as well. Okay, so what do we do with Vectara? Quick, kind of high level. RAG, there's a lot of ways to do RAG, but one thing that makes us unique, I think, is this ability to do, it's an end-to-end platform with an API. So when you create RAG, you have to extract data from documents, if they're in PDF format or whatever sometimes. You have to chunk the data, encode the data with an embedding model, index it, and then when a query comes in, you have to do the whole retrieval, re-ranking, generation with the LM. All of that are, somewhat easy to do when you do it with a single PDF, chat with my PDF kind of example we've all seen in 2023. But when you do it with hundreds of thousands of documents from hundreds of sources or whatever, it becomes really challenging, and you have to do it right, and it's really easy to make a mistake. And what we do with Vectara essentially is we put it all in a box. We manage all of that complexity for you, and all you have to do is use an API wrapper around it to send the data in and query the data from there. So it's really easy to build RAG pipelines that scale up and down, have security built in, and all the enterprise bells and whistles that you might want. So that's a little bit about us. And so I want to tell you the story of how we integrated with Airbus. It's actually a pretty cool story historically. So again, we started in 2023. Everybody, as I said earlier, built their chat with my single PDF. It was like, I write 5 lines of code, look at me, I'm a hero, I use LLMs. But when you go to enterprise scale, things become more complicated, right? You have moving to a lot of documents, is where I'm talking in the next slide of how Airbyte really helps with that, because moving a lot of this data into our platform, in a robust way, in a way that does refreshes and all that is really important. Accuracy, again, when you have hundreds of thousands or millions of documents, retrieval accuracy becomes more important because you have more facts fighting for the same spot. When you have one document, how many facts can you have there? How many chunks of data? When you have hundreds of thousands with maybe revisions and all kind of stuff, it becomes more complicated to do it, right? And RAG is like this garbage in, garbage out. If you don't get the right facts, you're not going to get the right response. I talked about enterprise security and privacy. When you go to implement RAG in your company, there's some stuff the CISO or the CIO, whoever, will demand, and it's just normal for any deployment. So those will come as table stakes requirements. Talked about explainability, citations, and like any project in an enterprise, there's things we always need to worry about. What's the latency? What's the cost? What's the uptime? And business continuity, things like that, that, again, when you do a demo for one document, it doesn't really matter, but when you go to enterprise, it becomes important. So essentially, the integration with Airbyte is really powerful, but quite simple. It's a destination connector. And so this allows us to take any of the, is it 350 more now? I don't know, 360. There's a lot of source connectors, Google Drive. Everything you want in enterprise actually is included there. There's a lot of different things. And you can take all of these things and just directly through, with ease of use that, Janet has shown some of the demos earlier. Like, it's a very easy platform you take. You can configure it. You can use PyAirbyte to do it your own. All these options exist to take any source in your enterprise and ingest them into the Vectara platform, and then you can then build the second part, which is the query part that you want to integrate in your application, right? So lots of benefits for our customers. Makes the data ingestion very rapid, very easy to use, with a lot of sources. They ingest into Vectara, just happens automatically. The connector implements all of that code and all of that API calls, etc. And how it happened is kind of interesting. So we started talking late last year. It was actually a hackathon organized by Airbyte, where somebody created a PR for this destination connector. And I got a note from the Airbyte people said, hey, we have something here. This is really interesting. So it was a pretty good, I think it was like 70 or 80% of the code was there. I personally took it and brought it with help of a lot of support from Airbyte engineers to get it to the finish line. And then we had this PR merged and tested and everything. And then we did a big release in January. We did a webinar together. It was a very, very good partnership all around in that sense. We did a blog post together. It was well received. And then we now have these monthly or weekly or bi-weekly meetings where we keep talking about shared customers and problems they see and new source connectors that we see a demand from the customers. And one example that came out, for example, is Box, right? So like, there's a really good relationship in terms of how both organizations work together to help our shared customers, be able to implement, RAG with both platforms together. So it's really, really nice. We also did this PyAirbyte kind of integration as well. I did a blog post about this together. So very, very good collaboration all around. And then I'm not going to show you a demo just for lack of time, but this is a little bit of how this would look in a screenshot format. Again, you create, this is an example with Zendesk source in this example, but I'm sorry it's a little small, but I don't know if I can make it any bigger. But I'll point out and share, like this is how you define kind of the settings on Zendesk. And then, so first you create the Zendesk source. Here we configure the connector. This is what the Vectara destination looks like. So you can define a couple things here in terms of the Vectara customer ID, the corpus ID in Vectara where the data goes, the authentication. and you just run it, and the output, looks something like this. This is an example application that does question and answering on top of all the data that you just, again, multiple sources. It'll just look and do that across all of those. And with that, thank you very much for listening. I wanted to share a couple of resources. If you want to try out Victara, here's a link for that, or you can scan the QR code. Again, we're an API platform, so we have the documentation. Here's our Discord, if you're interested in that. There's some sample code, a lot of demo applications that show how the application looks from a user perspective, chatbots and the like. And the 2 blog posts I mentioned are right here. And then if you're a startup, we also have a startup program to get you started with some support from us for Victara. And thanks for listening.
Questions. I'm going to see if he does want to go ahead and share anything on the screen, like demo-wise. But questions for we have people.
Yeah. So basically, how do you see RAGs evolving now that we have speech-to-speech models? Because in speech-to-speech models, there is no text involved, right?
So I think the question was, how do RAG evolves into speech-to-speech?
Yeah.
So you mean like I'm gonna, instead of typing something, I'll talk to it.
Yeah.
And my question, it will respond with answer. Kind of like what Siri was supposed to do, essentially, right? But without the RAG in the middle. So yeah, I think speech input and speech output, and I think the RAG is kind of in the middle of it, and that's how it's going to be. I think some of the challenges there is it needs to be kind of in semi-real time. You don't want to wait, like you ask a question, you wait for 10 seconds, and then you kind of like get the response. So I think on all the levels of that speech-to-speech platform, I think latency right now is the most difficult challenge. But it's being solved. People are working on it.
I'm from Victara also. That's one of the comments there. We actually have a partner called Play.ht. They put out models that do speech to text and text to speech. And so they'll do exactly what we just said. Someone will call a telephone or talk to you, and then it will automatically transcribe it, send that as a query request. It works, but so what they do is they use us just for the retrieval part, and they've got a very, very low latency. It's not an LLM like an LLM or SLM, small language model. It will go very fast to summarize what we send back, and then they'll send us like that in a voice. So like latency, you're right. That's the big key. The language models are getting faster and faster, like big language models. But right now, like you have to sort of customize the model to make it come back to a natural time. It's happening, sure, already.
Yeah. Thank you, Justin. Thank you. Good mention. Yes.
So always wondering when is RAG, what's a good use case for RAG, right? So I'm sure you have like some kind of a mental model, or maybe some variables based on which you determine if RAG is the right way to go.
So the question was what use cases are really good for RAG. I think, remember, RAG is it's based on text, based on natural language. And the use cases we see very often are chatbots, like customer support chatbots, or chatbot on any data that you want. We also, internally, for example, we have all of our stuff for Victara. We have Google Drive and Jira and all this stuff kind of being crawled, and we search. I mean, actually, it's much better search than all these other ones. So search on, ask questions, about internal resources, things that are externally are exposed to your customer, like chatbot for customer support is very common. Research, people have a lot of internal knowledge, and they just want to go and read 100 pages and just want to ask questions. So similar to what ChatGPT you would do with ChatGPT, but you can direct it at your own data, either internal or external or both.
Would you use it for something like a location glossary? So for example, to determine if a user's input is San Francisco, if it's San Francisco City, San Francisco, Bay Area, that kind of thing.
Sorry, can you repeat the question?
Yeah, if you would use it for something that's pretty specific, but still has some fuzziness, level of fuzziness, so location glossary, for an example.
So I would say, it's really good at understanding language nuances. So if you say San Francisco, you make a typo in it or use a different language like German or French or Urdu or whatever to do it. It's really good at that. But if you wanted to like disambiguate like San Francisco Bay Area, it really depends on the data that you feed it, right? It's not magic in that sense. Whatever, if you have a really good glossary and you put it in, it might work for this application, but you know, I'll make that statement. LMs are not magic. They look like magic. We just kind of got them to know this year, and but they are. They really depend on the accurate. In RAG, for example, they depend on the accuracy of. They depend on the data that you have and the accuracy of a retrieval model. And that's why we spend a lot of our time at Vectara getting the best embedding model, the best retrieval engine that we can, because that's really what it's all about. Yes, another question here.
Do you see any value to fine-tune the ranker inside the RAG for like different customers?
So the question was whether we want to fine-tune
The ranker.
the ranker. So people talk. So let me unpack this a little bit. I think there's terminology is a little bit confusing, and I know there's a lot of people talking about fine-tuning in different contexts. So the re-ranker itself is just a component of a two-phase retrieval system that usually happens at the end. I've not seen people fine-tune re-rankers. I've seen people ask me the question of like, should we fine-tune the language model that does the summarization in RAG? And it's a question I like to answer because I think there's a lot of confusion about it, and I'll tell you my point of view on that. So the short answer is, right now at least, no. And I know a lot of people tell you now, yeah, you should take your data and fine-tune it on your data and you'll get better results. That is theoretically possible, but I've done a lot of fine-tuning myself when I used GPT, and it's actually really hard to do it right. You usually have too little data. You have to prepare data in a very special way. You have to have a lot of expertise of how to stop and when to stop the training process. And it might forget something that it knows. Like these LMs are really powerful. They know a lot of different things that we tune very carefully, and you're kind of shifting the training around a little bit. So I would say a good person I work with from called Walid wrote a really nice, he used to work at Anyscale, wrote a really nice piece about this, and I recommend you read it too. They say fine-tuning is for form and RAG is for data. So fine-tuning, for example, can be trained to do better skill acts, better classification, better like it on a different task. But if you want to use data, you use a RAG pipeline. That will be my recommendation.
So,
Just over here.
yeah, just to kind of go back to that question, another question about like if you have a bunch of users that are kind of, and you wanting to query like San Francisco area, like the thing that popped into my mind was you would probably want to do like a kind of revise the model with like a LoRa type thing, and to tell it to, you know, do like San Francisco area or DC area or whatever.
Mm-hmm.
So I guess you're saying that you don't really see the need for that, or?
No, I'm saying I was trying to kind of guess with very little data about the use case of whether it will work well or not, right? And so I think the problem, the way I understood it was, if I'm telling it some sentence with San Francisco, but I use a variant of that word, would it actually work okay? And is that?
Well,
sorry, go ahead.
yeah, I was, so I mean, I don't know his exact question. I was thinking you have like log data and you're saying you're coming from like Half Moon Bay or Montero or whatever, or you're coming from like Oakland, and then you're typing, show me the users in the San Francisco area, right? And so you want all these other areas that don't say San Francisco in them, right?
Yeah, so again, it could work because it does understand those semantic connections, but I have to look at the specific use case to give you a more precise answer, right? It really depends on the use case.
Yeah, can you explain what I meant is that
Yeah, do we have
Actually,
more time?
so sorry. Save it though for the after part, because you can't ask him while
Yeah,
he's here.
I'll be here for a little bit longer, so
Yes.
please come ask me any more questions.
Let's do a round of applause, please. All right, everybody. That concludes our speakers for the night. We still do have a few more slices of pizza. There are still some drinks available. People are going to hang around for a bit. We probably have about like 15 to 20 minutes or so before everyone does need to get out of here for the cleaning staff. So thank you for joining us. We really appreciate it. Hope to see you at the next edition. And thank you to our partners, Ofer, Janet, everyone at Victada, everyone at Zerdito. I love working with you all. Looking forward to things to come still. Thanks, everybody.